Yeah, good morning to all of you. In this lecture, I am going to explain the concept of electric potential due to a dipole. So, what is dipole? I have already explained in previous lecture that dipole is an arrangement of two simple point charges which are separated by a certain distance. So, we have two point charges. We have plus q charge and this is minus q charge, which are separated by a certain distance. Let's say this distance is d. So we know the simple dipole moment in this case is defined by q into d, separation distance and charge. So this is the definition of dipole. And what is our objective in this lecture? In this lecture, our objective is to find out the expression of electric potential due to this dipole. So we know potential is a scalar quantity and we want to find out. So this is the point P where we want to find out the electric potential whose distance from and the distance of this, the distance from plus q charge to this point where we want to find out the electric field is simply corresponding to plus charge is r plus and correspond distance from this minus q charge to this point is simply r minus, and distance from this point to middle of this point, let's say this is, which is, if this total distance is d, then half of this distance is simply d by 2 and this is the d by 2 and this distance is r. Let's say this distance is r. So this is the schematic of electric potential due to a dipole. So with the help of this schematics we can find out the electric potential. So what is our job? If we can, our first job is to find out the electric potential due to this plus charge and then due to this minus charge, and this is potential is a scalar quantity, so we can find out, we can simply add this potential. So the potential corresponding to this charge is V plus and this charge is simply V minus. And what is V plus? We know the electric potential due to, I have already explained in the previous lecture that electric potential due to a point charge the electric potential due to a point charge q is simply 1 upon 4 pi epsilon 0 q by r. So in this case, if the charge is plus q, so what is the potential due to this plus charge at this point is simply V plus. Let's say V plus is the potential due to this plus charge whose distance is r plus. So this is 1 upon 4 pi epsilon 0 q by r plus. And what is the potential due to this minus charge is simply 1 upon 4 pi epsilon 0 q by r, but in this case our q is simply minus q. So the potential due to this minus charge is simply V minus, which is 1 upon 4 pi epsilon 0 minus q by r minus. So what is total potential? Plus V minus, because this is scalar, so we can add this to potential. So we have simply 1 upon 4 pi epsilon 0 is common to both and q is also common to both. So if you will add, so this is q and this is simply 1 by r plus, but we have a minus sign, so this is plus minus becomes plus and we have 1 minus r. So this is the profile of electric potential due to this dipole arrangement. Dipole is an arrangement in which two charges are separate, two plus minus q charges are separated by a certain distance. In this case, this distance is d. If distance is twice d, so we have a different expression of potential depending upon the choice of this distance. In certain books or textbook, if this d is replaced by 2d, So this distance is simply d and d. So mind it. So we have some numerical changes in our final expression of potential. So it depends upon us that if so what is our job in this case. Our distance, separation distance is simply d. So whatever be the potential profile corresponding to this separation distance. But if the distance is 2d, so we have a different profile of potential. So just mind it. So this is r plus. If you are able to find out this r plus anyhow, r plus and r minus, then we can easily find out the potential due to this dipole. So how to find out this r plus and r minus? Let's say this angle is theta. Let's say this angle is theta or this angle is theta. So we can easily find out the potential by using simple, because we have two different types of triangle. Let's say this is triangle 1 and triangle 2, and we can apply a cosine law, which is a square plus b square plus minus 2ab cos theta. So using this entity we have r plus, r d2 and r. So with the help of cosine's law we can easily find out the value of r plus and r minus. So applying r plus, applying cosine law on this triangle and this triangle separately, and evaluating, rearranging and evaluating, so we will have a final profile of electric potential, which is simply V equal to 1 upon 4 pi epsilon 0 qd cos theta by r square. This is the profile of potential. And in another way we know qd is a dipole moment. I have already explained the concept of this qd. So this simply p cos theta upon 4 pi epsilon 0 r square. This is the potential profile due to this dipole or this arrangement. So this is ready-made expression, just mind it. And this expression corresponding to the separation distance d. If we have a separation is 2d, then we have a different expression. So please mind it. This is very important information about the potential, that our potential choice of our expression of potential is different depending upon this situation. So this is the final potential profile due to this dipole arrangement, and which is a function of r and theta. So we can say that this is the polar profile, r and theta. Our potential, in this case our potential is in r and theta profile. So we can express our Vr theta is simply p cos theta, where p is a dipole moment, 4 pi epsilon naught r square. This is the dipolar profile of potential due to this dipole. Now if we have a monopole, so we can generalize this expression. We can simply generalize this potential due to multipole. Due to multipole arrangement. So if we talk about the proportionality, so potential due to multipole arrangement is simply r power n plus 1. Is simply r power, let me rewrite here. So potential due to multipole. Multipole. So the proportionality is simply r power n plus 1. This is the potential, and the final profile of potential is simply p cos theta by 4 pi epsilon naught r square. So this is the general profile of potential due to dipole, and it's all about the expression of potential due to dipole, and this is the general for multipole expression. Okay, it's all about this lecture. Thank you.